This will be for the con exercise, probability with general multiplication rule. All right, so this is from the article, The General Multiplication Rule on Khan Academy. All right, so when we calculate probabilities involving one event and another event, we multiply their probabilities. In some cases, the first event happening impacts the probability of the second. We call those dependent events. In other cases, the first event happening does not impact the probability. We call these independent events. All right, in either case, we're going to multiply, and typically it's going to be a fraction. Independent might be a tiny bit easier because you just multiply the two fractions. It's basically, say the events are called A and B. It's basically going to be the probability of A times the probability of B. All right, and you would just multiply the two fractions. But when the events are dependent, you still have two fractions multiplied. It's just that you have to adjust the probability on the second fraction. So in this case here, when the events are dependent, it's still going to be the probability of A times the probability of B, given that A already occurred. All right, so it's really almost the same formula. It's just that in the dependent case, you have to adjust the second fraction for the probability of B, given that event A already occurred. You don't necessarily need to write these formulas when you do the problems. If it helps you, go right ahead. But in both cases, we are just multiplying the fractions, all right, like it says in the first sentence. So that's basically why it's called the multiplication rule. Regardless of whether it's dependent or independent, we're just multiplying. Okay, Julia is playing a board game with a spinner that has 6 equal-sized segments. So here's the spinner, and she is going to spin twice on her next turn. Assume that the outcome of one spin doesn't affect the outcome of future spins. Okay, so these are clearly independent. What's the probability that Julia spins a 6 followed by a 2? All right, so we are just multiplying here. We'll start with the probability of spinning a 6, and then we'll multiply that times the probability of spinning a 2. All right, and it says the events don't affect each other. So what is the probability of getting a 6? Well, these are all equal size segments here. And here's the 6. That's one option out of how many? Well, there's 6 total options, so the chances of getting a 6 is just 1 out of 6. Okay, and of course, the same thing holds with the number 2. Here's the number 2. That's just one option out of 6. All right, so 1 over 6 times 1 over 6. Multiplying numerators, 1 times 1 is 1. Denominators, 6 times 6 is 36. All right, we don't need the decimal. You could do it if you want to, and you would have to round off the decimal, or you can just do the fraction. All right, so for the fraction, 1/36. Hamid is playing a trivia game with multiple choice questions. Each question has 2 correct answers among 5 answer choices. Hamid has no idea what the answers to a certain question are, so he needs to choose 2 different answers at random. What's the probability that Hamid guesses both answers correctly? All right, so let's set up the 2 fractions that we're going to be multiplying. And why am I doing that? Because he has to guess 2 different answers. All right, so the first fraction represents the first guess, and the second fraction represents the second guess. All right, and we want to get the probability that he gets both answers correct, and there's 2 out of 5 correct. So for the first guess, the chances of him getting it correct are going to be 2 out of 5. All right. Now for the second guess, once you choose the first correct answer, there is only going to be 1 correct answer left for the second guess. And once you choose one of the 5 choices, there is only going to be 4 choices left for the second guess. All right, so for the second guess, the chances of getting it correct are going to be 1 out of 4. All right, and I would reduce the fractions before you multiply. 4 divided by 2 cancels, so 4 divided by 2 is just 2. Multiplying numerators, 1 times 1 is 1. Denominators, 5 times 2 is 10. All right. If you had multiplied these out, you would get 0.1. But I think it's good practice to multiply fractions. So in the box, it's just 1/10 for 1/10. Sammy and Hannah are finalists in a cooking competition. For the final round, each of them will select a card without replacement that will reveal what the star ingredient must be. Here are the available cards. Sammy and Hannah both want to get leeks as their star ingredient. Sammy will draw first, followed by Hannah. What is the probability that neither contestant draws leeks? Okay, remember that it said without replacement, so you are not putting the card back. All right, so Sammy draws first, so the first fraction will be for Sammy. And then Hannah draws second, so the second fraction will be for Hannah. All right, and they said you're not putting it back. And they want the probability that neither draws leeks. Well, let's see. There are 6 cards to draw from, okay? And how many of those cards are not leeks? Well, we don't want to look at leeks. We want to look at all the other ones. 1, 2, 3, 4, 5. So the chance that the person doesn't draw leeks is going to be 5 out of the total, which is 6. All right. And now, once Sammy draws a card and does not put it back, let's say, for instance, that Sammy drew something that was not leeks, like the cabbage. So we would cross that off. And now for Hannah, how many cards are left that are not leeks? Well, we just have 1, 2, 3, 4. And how many cards left do we have to draw from? Well, we have 5 cards left. So for Hannah, the probability that it's not leeks is going to be 4 out of 5. Notice the numerator decreased by 1 and the denominator decreased by 1. All right, reducing fractions. 5 divided by 5 cancels. 4 and 6 are both even. 6 divided by 2 is 3. 4 divided by 2 is 2. All right, 1 times 2 is 2 in the numerator. 3 times 1 is 3 in the denominator. All right, 2/3. Anna is a teacher who plays a review game. The game involves writing each student name on a slip of paper and selecting at random. All right, here's the makeup of the class, the grade level, and the number of students. Suppose Anna picks a name, replaces it, and picks a name again. what is the probability that neither of the students selected are ninth graders? All right, so she's going to pick a name and replace it, and then pick a name again. So the first fraction will just be the first pick, and the second fraction will just be the second pick. We want to find the probability that neither of them are ninth graders. Well, how many of them are not ninth graders? 10th and 11th. That's basically 9 plus 7. All right. And how many do we have in total? Well, we have 12 plus 9 plus 7. All right. And now for the second pick. Well, it's going to be the same thing because she picks a name and replaces it. So the second pick probability is going to be the same as the first. So let's see. 9 plus 7 is 16. And 12 plus 9 plus 7 is 16 plus 12. That's going to be 28. All right, so this fraction is really the same as this fraction. So let me fix that. 9 plus 7 is going to be 16. And 12 plus 9 plus 7 is going to be 28. All right, so the fraction is the same for the first and the second. Let's reduce that. 16 divided by 4 is 4. 28 divided by 4 is 7. All right, and this fraction is the same thing. Divided by 4, that's going to be 4 over 7. All right, so 4 over 7 times 4 over 7. 4 times 4 in the numerator, 16. 7 times 7 in the denominator, that's 49. And that is your final answer. If you do it by decimals, you have to round to 2 decimal places. But that's already reduced, so that should be it. All right, 16/49.